Hello, I'm Trevor Jackson.
My name's George Adams.
And we're Met Electric, and we'd like your assistance, please, to produce this thing, which is called the iPOC, Instant Power on the Go. We've got a prototype, which we'll show you working shortly, and we're going to show you how you can get power from aluminium. What we're going to do is we're going to use a small piece of this material, which is called cathode, and we're going to make a small battery with this just to show what it can do. So this has a white side, sort of grey white side, and it's got a black side. It's the black side that needs to contact the aluminium. This is just a piece of aluminium, ordinary aluminium. A little motor and fan assembly there. So I'm going to just connect this, which is the cathode, called the air cathode, because it breathes air. Air goes through this membrane and the oxygen splits and dissolves into the electrolyte, which I'm just going to make up right now. And all that is some salt water. So I've got a little bit of salt in there, and just ordinary plain water. Just make sure that's dissolved. So I've just made a salt solution. I've put a little bit on this, a few drops on the aluminium surface there. You can see instant power, and what's happening is the aluminium is starting to change to aluminium hydroxide, which sounds a bit complicated and technical, but it's actually just the same stuff that you've got in anti-acid tablets. Most of the soil around your house is made of it. Aluminium is the most common metal on earth. It's perfectly safe. We all know about aluminium, but there we are. It's producing useful power from a very small piece of cathode. You can see the size of that there, and even that tiny little piece is producing useful power. That's that part of the demo. What I'm going to do now is move on to a slightly larger demonstration, which is this. And this is really a bigger piece of cathode. There's the black side, there's the grey side, the air breathing side. The air goes down into there, into this bore, and again oxygen gets split through this special membrane and dissolves in the water, and it connects the circuits with the aluminium to make power. So we're just going to have a look at this. I've got some salt solution in there already. This is a piece of an aluminium bottle, a beer bottle I think it is, which is just slightly scratched at the bottom so that you can get at the aluminium. And I'll connect this up. And again, power comes on straight away. This time a bit more power because we've got a bit more area. So you can see you're getting free power from a piece of used aluminium in the form of an old beer can. You can use waste aluminium from the home to make useful power. And this will run for quite a while, at no cost really, no operating cost. So you've seen this strange object in the background. This is what we're going to call the iPOG, which is the instant power on the go. And this is just a mock-up of this. This is the air breathing feature on either side. And simply we'll just have a USB port, so you can plug in anything that runs off a USB and it will provide you with USB power. What we're going to do is show you the prototype, the working prototype, which will be transformed into this at the end of this project. So that's what we need the assistance for. We know that this works, and we're going to demonstrate to you shortly that it will power USB connected devices and other things too. So we'll do that in a few minutes.
Right. This is the prototype for the iPOG, instantaneous power on the go. We've got 6 air breathing cathode cells, each requiring a piece of aluminium to complete the cell. These are just put in quite simply, just slipping them in into place. In the real iPOG, you'd just be able to take the aluminium out and put it in, just clip it into place. It won't be any of the connecting up to do like I'm doing here. So just manually collecting them up. You can see it's fairly rapid as it is, but the real iPOG would be just as quick, if not quicker. What we'll be doing after this would be to fill the cells up with the electrolyte, and then we'll get some useful power out of it and give you a few demonstrations. Go. Right, we've got our salt solution, salt and water as per the previous example you saw. I'm just going to fill it up and put them into the each test cell. Again, this will be done via a common fill point. You won't have any of this messing around to do on the actual iPOG. Too much in it. Right, this is it needs a little bit of topping up in a minute anyway, but it should produce some useful power in the fan. There goes the fan.
I think it's just going to go again, George. Here we go. Too much power. Right.
Disconnect that a minute.
Okay.
As you can see, it makes the fan run fairly fast. And here we have a LED light. Nice bright, constant power. We'll now attach a USB charger to a phone. We'll just make sure the phone's active. Around. Plug that one in. Oh no, I plugged the wrong one in. Did that last. Right, there we go. That's it. There we go. That is now charging. Hopefully you might be able to see the little lightning sign on there that shows it's charging.
So with the iPod, which has 6 cells, you'll be able to drive a motor with a fan on it, if you want to, or some other mechanical device. Be able to provide very useful bright light. So if you're in an emergency situation somewhere, there's a flood, or you're camping, or you're on a boat, or you're sailing, or in the woods anywhere, and you wanted some useful power to what you were doing, you could do that. You put the lights on, and importantly as well, you can recharge your BlackBerry or any other phone and stay in touch. So that's the iPod. You can do other things, and we'll shortly connect up this small amplifier and see what that can do.
Well, as you can see, we've got a small speaker with no batteries in it, powered entirely using the USB, which is plugged in to our iPod prototype. And from this we can power up an electric guitar. Yeah. Okay, now we're going to plug in a Samsung tablet. Now we have the noise to say that it's recognised a power source. It won't recognise that, but I don't know if you can see the little icon down there. It's come up.
So we know we're going to be able to charge a tablet, and part of the development will be to include some of the protocol logic inside the iPod so that it will charge all the tablets that are currently on the market.